14.2, hints for homework 1, part 2, 2 questions. Number 12, number 14. Number 12 first. This question. So for this question, in our comprehension questions, we have 2 questions related to this one. Actually, the second one is pretty close to this one. All right, so here I just like to explain those 2 comprehension questions. The first one, CQ3, C7. In this question, we need to find the following expression that is an integer. B is an integer. A and C, you can try. It will not be an integer. All right, so first, let me show why B is an integer. Right? Why B is an integer. We need to use the golden ratio properties. 1 is phi squared equals 1 plus phi. Second one, 1 equals phi squared minus phi. We use these 2 properties, we can simplify phi squared plus 1 over phi squared. First, what is phi squared? Phi squared, by the first property, it is just 1 plus phi. All right? So let's just put there, okay? Because this is already very simple. So we cannot do further simplification. But the second one, 1 over phi squared. Now we need to try to make the denominator part as simple as possible. Okay? In order to do that, the commonly used method, we represent 1 using the second property. We try to do cancellation. Phi squared minus phi over phi squared. Okay? All right. Then I like to write this fraction term by term separately. How about that? Square. Separately. Okay? Then the first fraction, just the 1. The second fraction after cancellation, 1 over phi. Okay? Yeah. All right. Then still not good enough. So I want to do, further simplification. This time 1 minus, replace 1 by phi squared minus phi over phi. This time we can cancel out the denominator phi. Okay? So you can see 1 minus phi minus 1. How about that? After cancellation, phi in the parentheses, phi minus 1. Then after simplification, 2 minus phi. All right. So finally, phi squared plus 1 over phi squared, 1 plus phi, 1 over phi squared, 2 minus phi, positive plus phi minus phi cancel out, 3. It is an integer. So we prove that. So for this question, we prove B option is an integer. But this question is a special case of our current homework question, because that's the case for n equals 1 case. But for question number 12, we need to show for all positive integer n, this expression is an integer, is a positive integer. So to do that, so we need to use mathematical induction. Okay, Yeah, mathematical induction. Yeah, here, yeah. So this is another comprehension question related to our current questions. In that one, yeah, I give you the answer D. Yeah, but I like to show you why it is correct. Right. Here we need to apply mathematical induction. All right, yeah. How to do it? The base case we did. Previous slide, we did it. So next time, induction assumption. What is the induction assumption? We assume some statement correct. Yeah. That is very important. Yeah. We assume for 1 less than equal to k less than equal to m, this expression 2k plus 1 over phi to the 2k is an integer. How about that? Yeah. Induction assumption, we assume it is true. Okay. So now we need to prove okay, phi to the 2 times n plus 1 plus 1 over phi to the 2 times n plus 1 is also an integer. If we can prove it, then we're done. So we prove the whole statement is correct. That's the mathematical induction. The power of the mathematical induction. Yeah. All right, how to prove? So here, there is a, very smart trick. Here, let me give you that trick. Yeah. It is, we calculate this expression, phi to the 2n plus 1 over phi to the 2n. Then multiply phi squared plus 1 over phi squared. Why we do that? Based on our experience, based on our knowledge, background, based on our creativity, based on our intuition. Yeah. Otherwise, if you don't have, pretty good problem-solving background, this step, very hard. Yeah. All right. First, we know the first parenthesis is an integer. Why? Induction assumption, right? When k equals n, based on assumption, this expression is an integer, right? Induction assumption. Yeah. The second one, also integer, because that's the base case. We already verify it. So integer multiplies another integer, also integer. So this, the product here is an integer. Yeah. Let us expand this product. All right, so I hope you can do this work. 2 parenthesis n plus 1, the first term. Okay, all right. The second term, 1 over phi 2 times n minus 1. Why n minus 1? Because phi squared, the denominator, we need to do cancellation. Cancellation, so you 2 times n minus 1. Yeah. Then the next one, multiplication, that is phi to the 2 to the n minus 1. Then the last one, product, last two fractions, phi to the 2 to the n plus 1. All right. these four terms, we can group them, put the related terms together. So we get the first parenthesis, phi to the 2 times n plus 1 plus 1 over phi to the 2 n times n plus 1. Okay? They are related terms. Okay? Yeah. The second one, phi to the 2 times n minus 1 plus 1 over phi to the 2 times n minus 1. Parenthesis. Okay? All right. The second parenthesis also an integer. Can you see that? The second parenthesis also an integer. Why induction assumption? When k equals n minus 1, right? N equals 1 in that range between 1 and n, in that range. So the second parenthesis also integer. Then the first parenthesis must be integer. Why? Because left-hand side integer, right-hand side should be integer, right? Yeah. And right-hand side, the second parenthesis integer. If you subtract the second parenthesis from the left-hand side, you get the first parenthesis integer. So the conclusion is the first parenthesis integer. Then, that's what we want to prove in our mathematical induction. That's what we want to prove, the goal. Okay? Yeah. So we complete it. Yeah. Hope you can follow. Yeah. Mathematical induction and our computation here. Yeah. All right, so next question, number 14. Given an unordered array with 10 elements, what is the minimum number of inversion that the array can have? Yeah. So this question is not very hard. Yeah. But here, if you need some help, I can give you some direction to go. Okay? If you can solve easily, then you're fine. But if you need some help, hint, then I can give you some hint here. Okay? Yeah, hint. Yeah. First, I hope you know the inversion, the definition of inversion. Okay? Yeah. So the inversion is if index I less than j and the array element a of I greater than a of j, reverse order, okay, so not in natural order, reverse order, then we call this pair a of I and a of j an inversion in the A array. Okay, yeah. So that's the definition. Yeah. Now, given an unordered array, we know it's unordered with 10 elements. What is the minimum number of inversion that can possibly have, that the array can possibly have? Okay, yeah, that's the question. To answer that, first, we want to consider the minimum number of inversions in the array. Okay, yeah. First, we look at, is it possible to be 0? Yeah, because 0, the reasonable number we can look at for the number of inversion. right? The minimum possible number. Yeah. The answer is no. Why? Because if the minimum number inversion equals 0, then there is no inversion, right? Because in this case, if it's true, that means no inversion. So no inversion in this array. If no inversion in the array, that means array is ordered. Okay? The array is ordered, contradicts the unordered array condition. We are given an unordered array. So we cannot get an ordered case. We cannot. All right. So then, second question, is it possible to be 1? Yeah. If 0 not possible, then is 1 possible? Right? Yeah. In order to see if it's possible, you need to create an example. Can you create an example of 10-element array with 1 inversion? Yeah, 10 elements, you may feel too many elements in the array. So it may not be easy. If you feel working on 10 elements not easy, can you reduce that number? Can you consider 4-element array? Find a 4-element array with 1 inversion. Is it possible? That should be easy, right? 4-element array with 1 inversion. If you can do that, then you can easily generate to 10-element array. Because you have the pattern, right? You see the pattern in your 4-element array. Then you just extend your pattern to 10-element array. So then you can get the right example you need. Yeah. All right. So that's the hint part. Yeah. So to answer the question, I like you to have all the thinking part. The thinking part, very important. All the logical thinking part. I do not like you just to make your guess. Okay? Because multiple choice questions, you can just guess one of the options as your answer. That's not good because you don't know why. If you can do all the thinking steps I described here, then it will be much better. Then you will have very good understanding of our materials. All right, so let me start E.2.